morning, college algebra. I know it's been a while since I posted a new video online. If you've been looking at your videos and seeing something for a 5.5 or 5.6, you can ignore those videos. I don't know. I'm sorry, they weren't videos, they were assignments. I don't know why some of them eliminated and some of them didn't, but 5.5 and 5.6 are not going to be due. That's something that Hines has elected to say that it is not a requirement for us to do. But we've got 2 more sections to go before the next test. And again, on the 17th, there will be a practice test for you. And following that, I do not remember the exact date right offhand, but there will be a review and then a final exam. So I'll be posting the review very shortly. So, looking at this, we got 2x plus 3y equals 1 and x minus y equals 3. What we've got here is we've got 2 lines. Of course, these are not in slope-intercept form. They are in standard form, though. And what we want to do with these is we want to put them to where we can eliminate one variable and then solve for the other variable. And then after we solve for the other variable, go back and solve for the variable that we eliminated. You've seen this before. This was a requirement in Algebra 1. So this should, for the main part, be a review for you today. But let's look at this problem first. We've got this here. Now, we can't just straight up eliminate this one as it is. So, because 2x and x becomes 3x when you combine them, 3y and negative y becomes 2y. So we've got to outright eliminate one. So what we can do is we can take this equation and we will not change its value by simply multiplying everything in it by a positive 3. So when I multiply everything in here by a positive 3, I now have common terms with opposite signs, so that variable will go away. So let me just rewrite this. So we're going to have 2x plus 3y equals 1. And then when we do the 3, and I'll write this one in green, this becomes 3x minus 3y equals 9. All right, now when we combine them, we add them. So 2x and 3x is 5x. And again, the 3y and the negative 3y go away. 1 and 9 is 10. So we get 5x equals to 10. And one of the common mistakes made here is not multiplying the 3 by every term in here, just multiplying it by these 2 and then bringing down this 3. Got to make sure you're careful with that. Also, on your assignment that's posted online, there are going to be some that are just going to be nasty fractions. Just understand that that's going to happen on a few of them. And you may actually have one of the assignments that doesn't have any of them. But if you get a nasty fraction, just keep going with it. It's still very possible to work. Solving for x here, divide by 5, so we get x equals to 2. All right, so now that we've solved for x here is 2, we can go back to either one of these original equations and solve for y. So here I'm going to bring down this equation because it's got the smallest amount of numbers here. So I'm going to have 2 minus y equals 3. So bring the y over here, and 2 minus 3 equals y, so negative 1 equals y. So if these are 2 lines will either intersect in a point, they'll be parallel to each other and they won't intersect at all, or actually there'll be lines that are coinciding and they will have an infinite number of solutions. But here, we get x to be 2 and y to be negative 1. And that is the solution for these 2 equations. All right, now let's go to this one here. All right, we see here again that there are no terms that we can just add straight through. In fact, everything in here is positive, so whatever we multiply by, we're going to need to multiply by a negative. Let me just try to get rid of the x first. So I'm going to multiply the top equation by negative 2. So negative 2 times x is negative 2x. Negative 2 times 2y is minus 4y. And then negative 2 times 3 is negative 6. And then we have that below that 2x plus 4y equals 6. So we add these together. Okay, we're trying to eliminate the x's. The x's go away. But negative 4y plus 4y, that also goes away. So everything on the left-hand side of the equals mark is 0. And then negative 6 plus 6 is also 0. So we get a true statement here. So what winds up happening is these two lines are the same line. They are the same line. So from that, there are an infinite number of solutions. Now, what that does not mean is that the solutions are all ordered pairs. What we can do here is we can take this equation right here, and let's solve it for y. Now, this is something that you did not do when you were in Algebra 1. So we solve this out for y, so 2y equals negative x plus 3, and then divide that by 2, so we get y equals negative 1/2 x plus 3/2. So my ordered pair here is x and negative 1/2 x plus 3/2. That will be my solution set here. So what this is saying is I can pick any number for x. Let's say I pick 0. Okay, let's let 0 be x. Well, then when I plug in 0 here, I get 3/2. So one of the points would be 0, 3/2. That would be one of the solutions. If I picked 1, okay, I would have 1. Or let's pick 2. I'm lazy, I don't want any fractions. So let's pick 2 here. So negative 1/2 times 2 is negative 1. And then negative 1 plus 3/2 is 1/2. So that's another point on that. So you can get your infinite amount of points by doing this work here. A second thing is, let's just say that this number right here had been 7 instead of 6. And this would be 7 here. So now we got negative 6 plus 7 is 1. So in this case, we get a statement that's not true. So this one would be no solution. In other words, we would have parallel lines here, so they would not intersect. The next video we're going to look at solving a system of equations where we have 3 equations. And again, this is section 6.1.